Thank you, Marcin. I'll try to quickly share my screen so that we know that all techniques work. Can you please confirm that you can see my screen?
I confirm.
Yeah. And then I'll make sure that I have a window here so I can see you and see if there's any comments in the chat. Right. Well, welcome everyone. As far as I see, we are a good number of participants. My name is Deniz Koca, and I'm an assistant professor at Lund University, Sweden, at Center for Environment and Climate Science. But we're in the process of merging two or three different departments into a bigger department, which will be called Earth Science and Climate Science. My background is in fact, in environmental engineering, but since close to 30 years now, I've been working with systems analysis, systems dynamics modeling, looking into complex and dynamic systems and understand such systems with stakeholders, with mental models, and then build numerical models, systems dynamics models to understand this complexity and ideally, hopefully, come up with some proper sustainable solutions with some decision support tools with understanding this complexity, as I mentioned, but with all the feedback loops, the time delays, the changes in the systems in time, how to capture this and how to compute all these interactions. And talking about such complex systems, food systems is one of them. And I shortly realized that when I was chairing an initiative at Lund University, in my own university called Foods Faculty, 200 plus researchers, everybody, anything to do with food systems. We gathered these people together, and then you shortly realize that we don't have the same picture of what we're talking about. These brilliant minds in their own disciplines, in their own research area, focus area, teaching or research. So I struggled very much like how to ensure a common and a proper basic understanding of what we're talking about. So what I will present in the coming half an hour or so is that work. It's by no means an end product. On the contrary, it's just the beginning. We all need input from different disciplines, from different sectors to understand this complexity. But hopefully it will trigger some discussion. So maybe towards the second part of my presentation, we can have some fruitful discussions. With that, and also I should also mention that we talk about food systems, but food systems is definitely not limited to what I'll present today, because today I'll only focus on land-based food production. So aquatic ecosystem is not included in here. So it's agriculture, land-based. And most likely, perhaps you've seen and you've heard all the problems and the environmental major issues related to agriculture. Almost 1/3 of the greenhouse gas emissions is actually related to the food and the agriculture. We use 50% of what is habitable globally for agriculture. And for that, we extract almost 70% of the global fresh water for the activities in the agricultural system. And with the use of extensive nutrients, almost 80% of global ocean and freshwater pollution is directly linked to the use of these nutrients in the agricultural system. So eutrophication, one of the biggest global environmental challenges, is very much because of the agriculture. And the mammal biodiversity, bird biodiversity, we're talking about the poultry and livestock production, industrial level, meat and dairy production. It's a very, very big issue, and I will come to that issue during my talk. A very simple supply chain. So we do agriculture to produce the food. This can be crop direct for human consumption as food. or crop for feed so that we can feed our animal, and then we process that crop, we pack it, make it available in the market so that we can all consume. Everything, of course, is driven by consumption, human consumption, and there are, if not thousands, like hundreds of different criteria out there which shapes our consumer choices, preferences, whether it's the information that we have access to, whether the segmented values that we represent, the priorities that we have in our whole entire consumers' life. So there's so much, but I will not go deep into that. But mainly, perhaps, the population, global population is definitely, like ever-growing global population is one of the major driving force in the consumption side. But also the food culture, the education, what social network we belong to, what kind of information we get through the advertising, the transparency of that information is also. Those are the things, main criteria that consumers are highly dependent on. Let's come back to the primary production part. So we need resources. The land, water, the chemicals, pesticides, fertilizers, energy, the labor, and any biotic or abiotic resources that you can come with to run up and running this of the agricultural system. Looking into the land, and I am sorry, I have to say this, but because I'm just recovering from a flu, so sorry if I need to take a break and get some water to clear my mouth. Globally, if you look at the Earth's surface, it's only 1/3 is land, the rest is ocean. And of that land area, only 70% is habitable. And as I mentioned in my first slide, half of this habitable land is used for agriculture. And there comes the problem. So we do agriculture in this massive amount of area, land area, and almost 80% of these activities is directly linked to the meat and dairy production. So, and for what? To get only less than 20% of the global calories that we need and less than 40% of the protein. So there's a big inefficiency here, like to make all this biomass production, but get the calories and supply the proteins through animals. Maybe we need to think about that, how to make this as much more efficient and effective. And also to give you an understanding of like how much land we use for livestock production, you can imagine the entire Americas, the continent is, you need that much land to produce the feed for the animals. If you look at water, another resource we use very much in the agriculture, again, the inefficiency is there. The dark green bars, it's the amount of water that we extract. And the light green is actually how we consume in agriculture. The shaded area is like we extract on the cost of all the money, effort, energy, but we don't use effectively, the loss in the system. So inefficiency is everywhere. Looking into the pesticides and chemicals, you can see the major global agricultural countries or regions where we just spread all the pesticides. And you all know that the impacts of the pesticides, both for the human health, but the soil health as well. So I don't go deep into that, but it's a big major problem there. Similarly, the use of fertilizers, very much similar in these agricultural regions globally. We just use this is nitrogen, but same thing with phosphorus. And when talking about the phosphorus, maybe I should just have a look into this here as well. Now we're over, are we 8 billion now? Nowadays, global world population. But with the amount of the natural fertilizers, the manure, we can only feed half of this global world population. So we do need this synthetic fertilizers, artificial fertilizers, produced from phosphorus and nitrogen to be able to feed the rest of the other half of the world population. And there comes the problem. I don't know how many of you heard about phosphorus scarcity. Like everybody, if you go out, talk about climate change, any other person you step in the streets, they will talk about that. It's a big problem, global warming. If you ask me, I think the biggest challenge that humanity is facing is the phosphorus scarcity. Because without phosphorus, we cannot produce the fertilizers that we need to produce the food that is needed for 8+ billion people in the future. And there's no substitute for phosphorus. Looking into energy, these are US figures, but it's sick. We put like 10 calories of fossil fuel in the system to get 1 calorie of food. So inefficiency here in the way we use the energy. And I'm sorry. Most likely you've heard about the labor scarcity as well, the aging population in agriculture. Of course, it's not the entire world, but in the maybe Western and in the Northern Hemisphere, the elderly population in the agricultural sector and not the younger generation not taking over that role is a big issue. And we have experienced some really serious problems after COVID, and then some disruptions with the supply chain, of course. So there's a big pressure on the people, on the labor, agricultural labor. So that's another big issue globally, I would say. So the resource use in the primary production is problematic. I showed it in the first slide. The way we use the land, how it affects the soil fertility, the way we use land, how it affects the whole deforestation, and with that, the effect on the biodiversity, the water use, chemicals, pesticides, how it affects both the soil and the water, the quality and the scarcity of the resources, energy scarcity. Talking about biodiversity loss, of course, deforestation is one of the main driving forces, but the agricultural practices itself, the way we do agriculture in the last century is the main issue here, I would say. If you look at the last century, the beginning of the century, when you had, say, like almost 500 different types of lettuce, towards the end of the century, you end up with less than 40 different types of lettuce, just because industrial level food production to feed this many people, monocrops, which crops gives you the highest yield and you make most money out of that. With that type of mentality, we unfortunately have a big issue with the biodiversity loss. We all talk about global greenhouse gas emissions, the climate change. Apparently, of course, everywhere in the supply chain, there are emissions. But if you look into closely where in the system, we said that 1/3 of the greenhouse gas emissions globally comes from the food sector. But if you look carefully where it comes from in the food sector, it's the way we use the land, it's the way we produce the crop, and the livestock. So primary production is contributing most, like almost more than 80% of this amount, 1/3 of global emission comes from the primary production. It says fisheries here, but it's only the 1% of this 31%. So it's still like more than 80%. So the rest is only responsible for the 18% of the emissions, the processing, transport, packaging, retailing. And this is very important because, as I mentioned, when you have so many different brilliant minds doing excellent things in different disciplines, different sectors within the food system. So when I hear people talking to like packaging and logistic, they come up with this biodegradable, biocompostable, the packaging material. alternative to synthetic plastic. And then, of course, linking it to, okay, by using this type of material, we will address the emission reductions because we will substitute the fossil in packaging. Then I feel like stop there, because it's great that you come up with such alternatives, but the narrative is wrong there. Because if your aim is really actually addressing the climate change, emission reductions, there's not much impact here. The impact lies here in the primary production, as you can see. So, however, if you if you look at waste, which I will come in a second, the amount of food losses and waste, the amount of greenhouse gas emissions directly linked to the food loss and waste, it accounts for 6% of global greenhouse gas emissions. So globally, 1/3 of what we produce is considered as food loss and waste, and all the emissions linked to that loss and waste, it's 6% of the global emissions, greenhouse gas emissions. So if this was a country, it's the third biggest emitting country after US and China. So if you can somehow, with that packaging material, instead of saying directly we will substitute the synthetic plastic in the system and then reduce our emissions, if you can, if possible, find a way of like extending the shelf life and addressing the food loss and waste in the system, and indirectly addressing the greenhouse gas emissions from that end, then there's a big impact there. So these kind of narratives that we use, because we all are excellent in whatever disciplines we are in, we do great work there. And then, of course, we know a little bit of the emissions, the waste, and this and that, and try to link it directly without a in-depth and through understanding of like what these feedback loops are. Is it direct or indirect, and in what way I'm contributing to the what problem? So to be able to understand this type of complexity, we need to be a little bit careful and then dig into all this interconnectedness of the system elements. So yeah, if we similarly, as I said, there's emissions from everywhere. Let me just finish these emissions, but the major contribution to this emissions, as I said, the way we produce this industrial level animal production, which is almost like the 30%, and the way we produce the feed for the animal production, and also, of course, the whole deforestation, land use change to make the feed available for the animal. So if you add up all these things, feed and animal production, the almost 60% of the whole emissions coming from the food sector is directly linked to the animal production. So it's the meat and the dairy. And we need to do something there. The waste, again, waste everywhere in the entire supply chain. Of course, geographically it differs. These are some figures from China. In China, 27% of what is produced is considered as food loss and waste. And if you look into where in the supply chain it occurs most, it's with 45%, it's in the post-harvest handling and storage. Only 24% during the production, and only 17% actually in the consumption. And if you compare these figures with the European ones, in Europe, we say roughly 20% of what is produced is considered as food waste and loss. And of that, the vast majority, almost 46%, 3 of that occurs in the consumption. Compared to China, it was 17%. So that, of course, there's many different reasons for that. In China, it was the post-handling, the storage and post-harvest handling, which was 46, 45%, whereas in Europe, it's 24% approximately. So the cold chain, the storage facilities, the infrastructures that you have, all the culture, the way you value the foods, of course, the economical power to purchase the food, these are all different reasons for that shows the regional differences. And so far, I only talked about the environmental issues. Sorry. But there's so much on the socioeconomic side as well. The labor scarcity, I mentioned that, but the whole animal welfare, the extensive use of antibiotics to produce this much meat and dairy products globally. The way we handle the animals, it's a big issue. The whole food security, I mean, making food available in the market is one thing, but making it accessible to all is a totally different thing. Globally, we still have a big global injustice, food injustice. Close to 3 billion people, actually, which is in this moderate to severe and severe food insecure zone, meaning that there are people out there going days without food. And this is a big problem. I mean, you produce 1/3 of what you produce is considered as loss and waste. So it's not that we're lacking food. We produce extensive amount of food, but we fail when it comes to in the distribution. Not everybody have access to what we produce. Of course, if it's not accessed, then it's not consumed. It has a direct impact on the human health. Globally, again, close to just under 1 billion people considered as undernourished, mainly in Asia and Africa. And yet we have so much problem with obesity and overweight. Almost 2 billion people, over 2 billion people. And the amount of money that we spend just obesity and overweight related diseases, it's an enormous amount of money that put an extra pressure on the economic system. So as you can see, there's so much faults, like issues in the global food system, but our task is, okay, where are the leverage points? What needs to be done? How can we do things better? Yes, there are many things that we can do better. But if you ask me, I would say one area is definitely the one major leverage point is to do the primary production right, so that we don't use that much resources ineffectively and on the cost of all these environmental issues. So how to do the agriculture primary production right? And there comes the whole sustainable agricultural practices. Just to give you an example, there's so many other things that we can potentially discuss, but we don't have time for that. But if you address the fertilizer use, for instance, we know that we don't use the fertilizers in the right way. So, but if you want to do it right, then we're talking about from precision farming. There are different water management, land management, the whole livestock management that comes into the role of the AI, the digitalization, the technology, how to make sure that we don't spread all the fertilizers all around, but with the techniques that we use, what is actually needed. On the financial side, the whole financial incentives, like it's not the 60s and 70s, the green revolution, how we started to use fertilizers in mainly in like India, spreading all fertilizers all around everywhere, subsidized, if not like free, almost like very cheap. The true cost of food consideration, so it shouldn't be that way. We have to, like on the with the financial incentives, we can definitely control the way we use the fertilizers. The whole agroecology principles, I will come into that regenerative agriculture, but there are many different practices out there, from the soil level, from the crop to field level, even to the landscape level. With right practices, you can significantly reduce your fertilizer demand. Advancements in genomic technologies, like with the right plant breeding, you can definitely control your fertilizer use, make it much more efficient. even with the right selection of different types of crops, you don't have to go into geom, etc. I mean, using legumes, this nitrogen fixation ability of certain crops, you can definitely reduce your fertilizer demand. So this is just an example like to tackle with the fertilizer use, but there are so many other opportunities out there to address the resources and the environmental issues around that. And of course, I mentioned the whole regenerative agriculture because with that, you can actually, okay, there's no clear definition of regen ag, but we agree that we're talking about no tillage, diverse crop rotations, cover crops, using only the natural fertilizers, the compost or the manure, which means that you have to have the animal in the system. So without animals, we cannot close this nitrogen cycles, nutrient cycles. And with those, we can actually address all of the things that I mentioned on the environmental side, from the soil health, the biodiversity to CO2 emissions, and even on the socioeconomic side with the farmers' livelihoods, making it improved. So the first leverage point, as I mentioned, doing the primary production right. But the second leverage point is to reduce this industrial level animal production, which means that we need to diversify our protein sources. There are many different sources of proteins out there. And there we're talking about many different plant-based or the insects, the whole precision fermentation, cultivated meat, like as it's known out there, unfortunately, the lab-grown meat, but we're talking about to produce proteins directly from the animal cells or from the microorganisms like the yeast, fungi, and bacteria. So you can actually disconnect the animal from the system. When I say disconnect the animal from the system, it's not the entire animal, because if you've seen what I showed in the primary production part, we have to have the animals there. But to the amount where the biophysical system can, within the carrying capacity of the biophysical world system. But we don't have to have more than that. And that can be compensated with different types of proteins from plants, from fermentation, insects. Even I call the holistic, the grazed meat, doing the right part as a alternative to the industrial level of meat production. So to that end, maybe I can say a few words about, I see it's half an hour past, but so my research focus very much on the alternative proteins here, like how we can diversify the protein sources, but also how we do the primary production right, how we can provide this capacity building programs for the farmers to understand the principles of regen ag, agroecology, what can be done here, what practices are out there. But since I work very closely with high tech, with the big giants here in this alternative protein sector and the farmers, I know exactly the misunderstandings. I know exactly how they cannot communicate with each other. And that doesn't work, because without that understanding, there's no way that we can come up with a proper solution and alternative business models that covers the risks here in the primary production, that opens up the market for the new type of proteins. So we work very heavily on that end with EIT Foods. In EIT Food, we have a protein diversification think tank, which we established almost 3 years ago now. And there's there's so many different initiatives, but the one that I lead in EIT Food, it's called the Grow Project, where we look into this capacity building of the farmers for the regenerative agriculture, for digitalization, adoption rate, increased adoption rate of digitalization, and the whole circular bioeconomy, like what more value-added products can we provide to farmers, so that a possible reduction in their income with less meat production can be compensated with other ways of activities. And with the alternative proteins, so of course we need to screen like what other potentials are out there, both emerging technologies and what is existing. And we look into like the stakeholder analysis and identification. Who are these people who have the most power and interest in the system, and how we can work with them to make sure that this transformation can happen. But these are all complex issues, and so far what I've showed to you, it's nothing to do with the systems, applied system science. But if you dig in all these bubbles, there are parameters, there are interactions between these parameters, feedback loops, whether it's reinforcing or balancing, time delays in the system. So we need to understand how the systems work, how these things are interrelated to each other. And that means that a whole process of like this group modeling sessions, workshop with the stakeholders, co-generate the knowledge, understand the problematic area, the symptoms, and then identifying the root cause of such problems and where to intervene the system, the leverage point. So with that identified, and it's a process, it's a learning process. Once you conceptually model such systems, then you can actually identify, like formulate these connections with the right data you find. You can build this type of numerical models where, as a decision support tool, you can actually and make, okay, what if I change this parameter in the system? What would the behavior of the system in the future? So you have the chance to make this like integrated impact assessment under different future plausible scenarios. So these are the things that we've been doing. Of course, it's not an easy task. I mean, simple but wrong, but we know that it's easy to implement. This is what we've been doing so far. But there are other ways of doing that thing. To deal with this complexity is also complex itself, the procedure, but at least better than this wrong solution. So it's, yeah, it requires some commitment and time, but with that, I think it's plausible. And to that end, I should also say a few words about these two up and running Horizon Europe projects. One is called the Epic Shift, the other one called is Feasts. This we started 2 years ago. Epic Shift started a year ago. And in Feast, we're looking into cultivated meat and seafood. Partners with 7 million total budget. We have another year to go, but within that project, we will look into how you can get the cells from animals and feed these cells in bioreactors with growth medium that comes from the biomass from the primary production, of course. But the animals reproduce itself in these bioreactors in steel tanks, stainless steel tanks. So tanks, you don't need the animals. It's much faster. You don't need that much resources, such as land and all the nutrients. But the commission funded us to know about like the feasibility of this, how from the environmental perspective, from social and economic perspective, techno-economically, if it's feasible. If so, what kind of business model should be around that? Is it centralized or decentralized? What's the role of farmers in this new system? So we try to look into all this complexity. There are a group of people looking into LCA, environmental life cycle analysis, social LCAs, techno-economic assessment, nutritional and health aspects, regulatory aspects, because they are all considered as novel, so they are not approved yet in Europe, so you cannot produce and sell at the moment. But there are different countries out there, such as Singapore, Israel, US, they are all approving. Korea is coming, UK is coming, and the European Union, of course, they need to know what's the cost of inaction, because it's all geopolitics, war, who is dominating the power in biotechnology. It's a huge market as well. So we will try, hopefully, address all these questions with the modeling work. All the data that I mentioned with LCAs and techno-economic assessments, they will all feed into a systems dynamics model. that we will be developing here in Lund, and then we will be able to hopefully make this scenario analysis, integrated impact assessments, how much land we free up with this, with that, how much emission reductions we're talking about, because you free up land for feed production if you don't need that much animals in the system. So this is the FEAS project, but similar to a sister project, the Epic Shift is very similar, but not limited. This is only cultivated meat and seafood. Epic Shift looks into all different types of, from insect, from algae, from precision fermentation. So looking into the other novel proteins, other novel food that are produced from different alternative protein sources, and doing the similar things for that so that we can cover the entire array of this disruptive alternative technologies or alternative proteins in the system. I see there is only 20 minutes left, so I would think I will stop here and then open the floor for discussions or any questions that you may have. I'm quickly checking the chat. There's nothing there yet. Either just raise your voice or type your questions in the chat. But it would be nice to hear what you think about the leverage points to address the issues here. But of course, there's so many things that needs to be placed in right way. So I'm eager to hear what you think. And don't be too shy. Any questions to start with?
A question.
Yes, please.
Thank you for the lecture. About plant-based protein, like eventually if we want to produce them, we need to do a monocrop plant, like to plant legume and soya and this stuff. So we're back in the same point now. That's not healthy for the soil, and so maybe this is not the solution.
Only plant-based, I would say, no, it's not the solution, but diversify your alternatives with plant-based, yes, why not? I mean, and in a way, even though you say it's monoculture, monocrops, but I would say this part of the world, in Sweden, for instance, there's no legume production, no beans, etc. So, but it's coming. So in a way, it's like diversification here in this part. So plant-based can be a way of diversifying your crops and protein sources. And doing it in a regenerative way, it's only win-win. Because
but now how it's like, how they plan it now, how they plan the soya and this, it's not diverse, it's monocrop, right?
Yeah, but at the moment, I think the soya is mainly in Europe. We import all the soya from South America to feed our animal, and then we get the protein from the animal. So it's not directly from the soya protein that we eat. So we feed our animal and then.
Okay.
And that's completely wrong because we produce mass amounts of feed, like soya as feed. If we can reduce that, so it's only good.
Thank you.
You're most welcome. Atta?
Yes, excuse me, Professor. You mentioned
There is some echo.
you mentioned a little bit about the integrated impact assessment that you had. I was just wondering what was the best practice and what was the most impactful solution of all the solutions we've discussed here in this topic.
Yep. I don't have an answer yet because it's work in progress. So the modeling work has just started so that we can do this integrated impact assessment. But there, what we are after is, okay, if we can replace or substitute X% of meat and dairy in Europe with this type of alternatives out there, what are the implications? Like how much less feed do we need? Because if we don't have that much meat produced and consumed, that means that we don't need that much feed. Okay, what does that mean? You don't need that much land to produce that feed. Okay, with all those activities, if you don't do that, how much emissions reductions we're talking about? how much less water usage, how much less fertilizer chemicals usage. So we will look into that. And this is on the environmental. So there are certain like indicators that we will look into. But on the socioeconomic side, we want to see, okay, this new type of technologies, biotechnology, how many bioreactors are we talking about? Do we have enough stainless steel to produce that? Are we going to convert like already existing breweries into this? Is it going to be a one giant big factory or very smaller units, like even farm-based? There is already like in the Netherlands, some work is ongoing, like cultivated meats bioreactor at a farm level. So what you can produce in the farm, including the animal, the regular like regenerative agriculture around that, but you can also produce the growth media for the animal cells in this bioreactor, small mobile. Then you can produce both cultivated meat and traditional meat. So the whole economics behind that, how much money they can make. Yeah, we will look into how much job creation we're talking about, because we don't want to solve a problem and then create many other problems that we've done so far. So if we're talking about this transition, what is the important role of the farmers in this new system? Because they have to be in the central role as well, because they will still do the primary production. Without that, there's no growth media for the cells or for the microorganisms to feed. And for that, they need to have a role in the new business model. So we try to look into all this dynamics as well. How much further educated, maybe different capacity in the labor market. So we will look into all these different scenarios, but we're not there yet.
Yes, I agree that having a higher capacity for farmers would be a very good solution. Thank you, Professor.
Thank you. Zoib?
Yeah, hi. Am I audible?
Yes, we can hear you. I can't see you, but I can hear you.
Okay. Okay. Yeah. Thank you, Professor, for sharing the information, insight, and also the breakdown of the prevailing issues. My question is related to the dissection which you already did, that with respect to the proportion where we should give more focus in terms of the actions which we need to take. But my question is related to a generic and holistic approach, that because the numbers and this data probably is not the very new data. Maybe for so many years we have this information, but what do you think, in your point, what is missing link? Why we are unable to give more focus on the main core issues? Either we are working in the silos, or we are not having a holistic approach and overview sorry, of the overall food system. What in your point is the missing link which is not helping us? Because we all know that UN SDGs, there are a lot of other organizations who are working for so many years, even for more than decades even, but still the main issues, the key issues, the problematic areas are still there.
Thank you. Very good question. You're absolutely right. It's not that we're lacking information, we're lacking data. There's so much out there that we know. If we can do that, it should work, but we can't. And there are many different reasons for that. Not working collectively, not understanding in a holistic way, like the systems, food systems thinking approach, adapting that, lack of adoption of that is major issue, one of the biggest important issues, I would say. And to that end, maybe I didn't say much about that, but there's another third Horizon Europe project that we're a part of called FOSNet, Pan-European Academic Network for Food System Science. It's a 4-year project. The first year and a half is just gone recently. So the whole idea is to define what the food system science is all about. What is the framework for the food systems? What elements should be covered in the food system when we're talking about food system? So it's all about all these interlinkages, the feedbacks in the broader elements of the food system. And of course, food system, it's not in a silo. It's linked to many other different sectors from health, energy, etc. So we try to identify in Europe, this is a European project, but who are these people or who are these institutions that claim that they work with food systems? What kind of research they have or we have in Europe, and what is lacking? Like, we need to identify the gaps so that we can come up a roadmap for it with a proper, after analysis of that existing research agendas, a proper agenda for food systems research. Similarly for the education, we try to develop a curricula for food systems. What is lacking? What is existing at the moment? Analyzing that and come up with a proper curricula so that we can teach it the right way. So hopefully initiatives like this is just one project, but I think this is lacking, to have to bring this many different disciplines and sectors, because it's not only interdisciplinarity, it's about transdisciplinarity as well. So we need the knowledge, experience, skills from outside academia. There's so much out there that we need to bring into the discussions. So how to ensure that we have the right competency in food systems thinking approach. And there comes the whole, the generic, what I've been doing. In this case, we apply the applied system science into food system, but it's the same thing. If you apply it into energy or transportation, different sectors, but the core is understanding this complexity with the right tools, methods, approaches that the system science can provide you. So conceptual modeling, numerical modeling, and the whole process of like how to co-generate the knowledge that we can move forward. And of course, that means that since it's not only academia, I mentioned the transdisciplinarity dimension, but there we need, of course, the people in power, such as the politicians. They need to understand the way it works. Without that understanding, it's difficult to the top-down management of the system. Yes, grassroots movement is one thing, but we need both from the top down as well. Is it an easy task? Definitely not. Even though sometimes, even if they know what needs to be done, there are many other different hurdles, obstacles on the way. So how to overcome those things. Politicians, they have a 4-year like working period. They don't think about 100 years as I do as a modeler. So I can tell many other different things, but yes, we need to start from somewhere. But I think from the academic side, from my perspective, and then including the outside academia with the discussions, is to start with, I would say. I don't know if I answered your question, Zuhair.
Thank you. I think I'm able to get a good insight from your answer as well, that how we can focus on things and what is the missing area where we as a student also think to focus when we go down into this program.
And also, now I mentioned that, okay, the whole protein diversification and doing this part right. Yes, in theory, it looks good, but to scale up regenerative agriculture in Europe, it's not easy. I cannot go to a farmer and say that, look, you're doing conventional, you're using this extensive and intensive way of producing, do it this way, right way. They will laugh at me. Because if you do it that way, by default, it means that in the coming 3-5 years, you will lose yields, it's something new for you. There are certain risks, mainly economic. Who's gonna face for that? If you just leave everything to farmers, this will never, ever happen. So you need to have the right de-risking mechanism in place, new business models integrated into the different actors. But that's why we need collaboration. That's why the same thing for the alternative protein sector as well. If they only talk about the technology and the product, it will never happen. At the moment, they can have the best process, best product up and running, but there's no supporting regulatory framework out there. EFSA, European Food Safety Agency, says no. So without that, they cannot sell it. And this is just one example. And even if it's there, without the consumer acceptance, that will not work. You need to inform the consumers why this is better or worse than the other. So it's all about being very transparent, being very open for collaboration, so that you have a good narrative covering all possible aspects, so that people stop complaining, so they don't stop you on the transformation. Otherwise, we just talk, and if we move, it will be very small steps. So if you want to accelerate this transformation, we need a good narrative covering all aspects from a holistic view. That's where the importance of the food systems thinking approach comes into the whole discussions. Any other questions or comments? Okay, I see some questions here in the chat. Ooh. Hi, as nearly 1/3 of the food process is wasted and most of its own consumption, would it be better to focus more effort on the rather than enforce plant-based products and cultivated meat, which would take longer time to apply and of course, I mean, waste generation is definitely one key issue, which I didn't mention here. Definitely. I mean, we need to work on there. We need to work many different aspects here. It's just like the way we produce the foods with so much focus on meat and dairy with extensive and intensive farming, that's a major issue. So we need to take that part away. That was my entry point with the alternative proteins or the diversification of the proteins. When we talk about how many species of fruits and vegetables we consume and the strategies to prevent biodiversity loss, how we can engage farmers into adhere to those alternative species, sometimes they're not the most lucrative for them. For example, in my country, many small farmers rather partner with big farmers to produce soy instead of regional vegetables because it's safer. So, of course, it's all about this. I was in Norway talking to Norway's biggest organic carrot producer. He told me that he can produce everything, 100% of what he produces in the organic way, but the retailers, they don't buy it. So they are the monopoly in the system. The retailer, they want this, and then you need to produce that thing. It doesn't really matter what capacity you have to produce in what better way than what potentially can be done. He had all the technology, so he was very frustrated about the way it was. He has the potential to produce and do it right, but the system doesn't allow him. And this is exactly what I'm reading here. And this is why in the discussions we have to have the retailers, farmers, consumers, a full business model. So if you just go to farmer and say that do it that way, it will never work. But if you go to farmer with the retailer or with the big food processors like Danone, PepsiCo, and with the regional or the city neighborhood city, as a consumer with their public procurement power, if you can go there and say that, look, we want you to produce that way, this type of crop in a much more sustainable way, and we ensure that we will buy this from you, so that the processor can produce the product, whether it's the plant-based or any other. I mean, it can be like alternatives to dairy, plant-based with dairy. And the municipality or the region ensures that there's market, so they buy this product. So if we come up with such a business model, then only you can convince the farmer. Otherwise, impossible. Somebody left. Taking into account Bianca's question, how can we include other leverages such as industry into including more diverse foods such as native local food? I think I just mentioned the role of the industry here. So they need to be a part of the business model. Because in Grow project, for instance, the capacity building project, even there we have difficulties to reach farmers, to convince them, come and listen us, or let's learn from you. What is lacking? What are your challenges? So that we can shape educational material for you. We can find the right peer-to-peer learnings, what we can learn from the best practicing farmer and then replicate it to others. if it's only with farmers, it doesn't work because as the other participant wrote, like even if you know what they should produce and how they should produce, if the retailer or the producer industry doesn't buy, then there's no way that they want to go for that way. But if we approach these people through the industry, because like Danone, they have programs, certain programs that they work with like 100, 200 farmers, and they buy, they are their suppliers basically. So if we approach these farmers through such industry, we realize that it's much easier. They accept to take part in our educational programs, capacity building programs, and they do it the way. So it's important to include the industry and the retailers in this whole transformation. Okay, now I guess I answered all the questions in the chat. If there are any other questions, I'm happy to answer, or last comments. There's 1 more minute left. Otherwise, you can always send me an email, drop me a line. These are my contact details here as well. One more thing. One of the area could be to value chain improvement through which they can understand the benefit they will get if they produce regional vegetables also. One of the area could be to, I can't hear, okay, to work on value chain improvement through which they can understand the benefits and they'll get if they produce regional. Of course. Okay. Thank you very much for listening. I think I will stop here now. And good luck with your studies. And as I said, drop me a line if you have anything further. Thank you.
Thank
Bye-bye.
you.
Thank you
Bye.
very much. Thank you very much, Professor.
Thank you.
Professor.
Thank you. Bye-bye.
Thank you.
Thank you.
Bye-bye. Thank you. Thank you. Bye.